Okay, so today let's look at this other example. It's a mechanical system, and we're going to review the process on how to produce the bone graft model of this. Choose, it says this, to develop a computer model for entering for a computer simulation. You don't have to do the actual numerical simulation, so we need to build the bone graft model. I think what I'm going to do at first is I am going to review the processing here that we use to produce this this model. So I am going to look at my blue pen, and I'm going to write what is the first step we need to do. Let's call it 1 step. What's that we need to do? Recognize the elements present, yeah? I would say the system elements. All right. And then if that's the case, what kind of, let's do it together. What kind of element is this one? What element is this one? Nobody? R element, right? Here we have another R element. How about this one right here? This is an I element, yeah? This too is an I element. And so is this. This is an R element in here, and this is a C element. What about this one here? It's telling me that I have a force applied over here, huh? Force applied here, so this would be an SE. This would be my reference, which is an SF element with velocity equals to 0, yeah? And then okay, so that's that. We have had all the elements in here. It says there's no friction on this, but it says there is friction over here. So if there is friction, what kind of element would there be in here? Yeah, and so it would be here too. So we have now a good handle of what is that we have. So what would be the step number 2? You could say use a 1 junction to do what?
Represent the distinct velocity.
Yeah. Represent distinct. I'll get better. This is, can you read okay? Can you read my handwriting okay? Okay, good, thanks. So, okay, let's go over here and we say, okay, this is the, I would say for this, let's just give it some name, you know, this is the, I would say this is the x1 dot here. Really, this is the x of 2 dot, and you have the x of 3 dot over here. I would do 1 for this, and so I would put the 1 junction for this x of 2 up here, which would be like this. Then I have 1 over here for x of, no, this was x of 3, x of 2, and you have a 1 for x of 1 dot, and I would add 1 for the v equals to 0. So those are the recognized elements. We use a one junction for the distinct velocities. Then you will say 3. What do we need to do? We need to attach the elements that experience what? Those velocities. Yeah, writing here with a little tablet is is a challenge because there's no friction, so you really have to write well. Okay, anyway, so in here we do that. We'll attach this SE over here. Then obviously this is a I element, so we're going to put it in here with M sub 2, of course. This one right here is the I element with M sub 3, really. And this one right here is the I element with what? M sub 1. And then you have in here the SF, which is in here like this, with velocity equals to 0. Okay, that completes step number 3. What about step number 4? What should we do on 4? On 4 we use a 0 junction for each relative velocity. So okay, let's do that. There's relative velocity between 2 and 1, and then relative velocity between 1 and 2, 1 and 3, and 2 and 3. Wow. Okay, let's go slow. Let's go on this one. M1 with the wall has a relative velocity. Let's just see like this. And so this would be x1 dot minus v0. And that's this one. You have also a relative velocity between this 3 and the wall. So I would do between this and this. Okay, let's just put the 0 here between that one and this. And this is going to be can I put it on the side maybe? Well, we could try that, but hopefully don't miss. This one is x of 3 dot minus b sub 0. That's the difference between this and this. This and this is over here between 1 and 3. And there's one between 1 and 2. Okay, so there would be one like this. See, in here, one thing we gotta realize, this is pulling, yeah? So it's like by default, m sub 2 is the, x sub 2 is the largest one. So between x sub 2 and x sub 3, we can very clearly say this. And this would be a 1, which would be x sub 2 dot minus x sub 3 dot. Okay, so now if that's true, between 3 and 1, then this is the other way. It's like this. And then this. Yeah. And then you have this one. So 3 dot minus x1 dot. Okay, what other differences we have between these two? We also have between this one and that one. And that produces x sub 2 minus x sub 1. Right? So, okay. Now let's go one by one. The difference between 2 and 3, which is this and this, is seen by this friction element, which is well, but that's, we're on 5, so you could say attach elements that experience the relative velocities. Okay, so if this is true, in here I'm just going to change color to, let's just do it with this one. Okay, so in here we will have to add the R element like this. We also, between those two, we have an R element, which would be like this. Yeah, there's no friction here on the bottom, and between this one in here is 1 minus b sub 0, which is, this is, just write it down a little nicer here. This is a 1 in here, which would be like this. Yeah, it's 1 x1 dot minus b0. That one will have this R element, that one. Okay, now so we got this one covered, we got that one covered, we have this and this, so that's this one, and then